Estuaries are really, really productive habitats, and a lot of people don't realize it because when you look out here, all you see is what looks to be yucky mud and stuff hanging on the rocks, and it smells funny, but all of that you're seeing is just a result of the productivity. You look at the surface of the mud and it's covered in algae that's visible, but there's also all the microscopic forms of life, diatoms and dinoflagellates and bacteria, and the food chain is so rich that it's one of the most productive habitats on Earth. So when you look at this microscopic, numerous life forms in the area, they support a huge number, huge populations of organisms. But a lot of people look out and just see mud and kind of weeds, but as the tide moves in and out every day, a couple times a day, it flushes the area, it brings nutrients in, and then it carries the food material that's produced here out to other habitats. And so not only does it create productivity right here in the estuary, it also feeds organisms out in the ocean. We've got fish right all around us here too. See them sitting on the surface? They're probably smelt. We have a lot of different kinds of smelt, small silvery fishes. And a lot of times you'll see that's what the cormorants are swimming after underwater, and that's what the terns are diving to try and catch too. We get a lot of top smelt. There's little smaller fishes, young fishes jumping out here too. It's a double-crested cormorant. They're related to pelicans. And we have Forster's terns sitting on the buoy. Terns are these little guys. Fish-eating, diving birds. Very common. They feed on small species of fishes that are common in the estuaries. And terns, we have a number of species of terns that breed here locally, and one of them is the endangered least tern. But these are Forster's terns. If you look at the color of the mud, you'll see that it's kind of a brownish, kind of orangey brownish in places, and that's from the diatoms. And diatoms are these microscopic single-celled plants or protists, depending on who you believe, but they photosynthesize, so they're taking sunlight energy and producing food, and they're producing oxygen, and then those diatoms and similar organisms called dinoflagellates are filtered out by filter feeding animals like the mussels and various kinds of worms. And then those in turn also produce products or are eaten directly by other organisms. So it's a really, really rich habitat. All of this organic material is broken down by bacteria, and the bacteria themselves are eaten by organisms. And then numerous of this organic material that's being made, there's hydrogen sulfide as one of the byproducts, and that's what gives it that kind of sulfury smell when you're smelling an estuary. And a lot of people go, oh, it smells like rotten eggs. Well, yeah, it does, but that's a sign of productivity in this area. Some of the stuff that you're seeing down here on the bottom is this Enteromorpha. This is one of the green algae that's so productive in the salt marsh. And this is, as you can see, a green plant. So it's producing food and oxygen in this shallow water all the way through the water column. You have productivity. And this is producing lots and lots of food for small organisms, lots of organic material for tiny, oh, well, even the bacteria all the way down the food chain. So we have that. And then I was talking about the smelly mud. You get this nice black smelly mud because of the bacteria. But this bacteria is producing materials that is food for other organisms. These hydrogen sulfide, that rotten egg smell that you smell, which is given off by bacteria, the hydrogen sulfide in turn is used by sulfur bacteria, and the sulfur bacteria take the hydrogen sulfide and make it into food chemosynthetically. So in an estuary, you not only have photosynthesis, you have chemosynthesis, and you have organic material being produced by both processes. So it makes an estuary very, very rich because of two kinds of productivity taking place. Most of your land-based ecosystems just have photosynthesis, but your estuary has photosynthesis and chemosynthesis, and that's what makes it so productive. One of the numerous organisms in the estuary, too, are these California horn snails. These horn snails cover mud flats and into the salt marsh. In fact, all these little black things up here on the exposed mud, those are all California horn snails. And these plow along through the mud and they eat detritus, this organic material. And then they, in turn, are food for other organisms. You can see the bottom here. Lots of holes in the bottom, and every one of those holes represents an organism. It might be a polychaete worm, it might be a bivalve. Oh, I just saw some eggs of looks like Navinax eggs. And sometimes if you just move along slowly, you'll see the ghost shrimp in their burrows, or you might see the mucus net from one of the worms. That's how they filter feed. But every hole represents an organism, and you can see how many holes there are. So that's a lot of organisms that are being supported in this estuary. This is the bubble snail, his little face. He's pulling his little face in. Very thin shell, so he doesn't really rely on his shell for protection. Part of his body, called his mantle, usually comes up and covers the shell. And then he's also very slimy. And living on his shell is another snail. This little bump you see right here, this is another snail called a slipper shell, Crepidula. And they live on top of bubbles and other snails. That's where you almost always find them. And the slipper shell is an interesting snail because oftentimes they'll stack. Be 3 or 4 or 5 slipper shells in a stack. And I forget, I think the one at the bottom's the female and the one at the top's the male, and they change sex. So if you separate the stack and restack them, the one at the bottom becomes female and the one at the top becomes male again. Very interesting lives they lead. All this stuff happens right out here in the estuary, and most people aren't even aware. Isn't he cute? Be free, be free. Shorebirds are really interesting, and they're set up to take advantage of these burrowing organisms in the mud flats. And when you start looking at different shorebirds, you see, one, you notice that their bills are different lengths, and two, you'll also notice that their legs are different lengths. So by having different length bills, they can probe into the mud to different depths. And at every depth in the mud, there are different organisms. So you can have a variety of different kinds of shorebirds out on the mud, all probing, sticking their bills down into the mud, and yet they're not competing with each other. Because each one of them, because of their different length bill, is feeding on a different organism at a different depth. And these are whimbrels. If you compare it to this curlew, look how much longer the long-billed curlew's bill is, and look at how he's using his bill. He probes underneath things, but he can also stuff that bill clear down into the mud. And these birds, these are all types of sandpipers, the long-billed curlew being the largest. The tips of their bills are sensitive. So when they probe, if they run into something, they can feel it on the tip of their bill, and just the very tip of their bill can be opened to take advantage of what they found. The killdeer is a type from another group of shorebirds called the plovers, and it has a short bill and great big eyes. And instead of probing, the killdeer looks with its eyes to find something and then walks over and picks it up. The two main groups of shorebirds, the sandpipers and the plovers, behave very differently. And again, they don't compete with each other. There he goes. Killdeer, killdeer, killdeer.
Oh,
it's nice when they say their name.
Yeah.
It's kind of a well-worn phrase, but wetlands are the kidneys of the watershed, and they act as the filter for the, especially the dry weather flows as they come down through the watershed. They're the final interface between the receiving waters, in this case the coast and the bays, and the inland watersheds. One of the biggest problems with our terminus wetlands like this one is that's at the end of the drainage is that most of the drainage has been channelized. So whenever there's a flow, and even during dry weather flows, massive amounts of trash come down, as well as the pollutants from the urbanized area. And there's really no excuse for it. There are a number of very simple trash net and trash removal mechanisms out on the market, and just the powers that be haven't gotten around to implementing them yet. And it's really, it hurts the economy tremendously, and it's not a wise decision not to invest in trash removal. The whole secret to cleaning up stormwater and contaminated runoff is to slow it down. If you slow it down, settling and sedimentation take place, and it turns out that a lot of the pollutants that are associated with the runoff, especially with urban runoff, become associated with the particulates that are in that runoff. So if you settle the particulates, you remove the toxins along with them. So things that get removed in the wetlands then get decontaminated in the wetlands also. There's a trend in stormwater planning that attempts to mimic some of these processes. And the few projects that have been done, some of them quite major, that have used these processes of deceleration, sedimentation and settling, filtration, infiltration, and interaction with biological communities, have generally saved money. Even though they use a different array of techniques, instead of big settling basins and things like that, they may put big pockets of gravel underneath a parking lot that will hold a lot of water and then weep it out slowly. Engineering is actually, even in hardscaped areas and heavily urbanized areas, is finally catching on to what the natural watershed processes have been doing for eons and starting to mimic it to everyone's benefit. But it's just incredible to see this with all the trash cleaned up and what it could really be. And to get out here in these little flat-bottomed, quiet little skiffs, and more people, I think, if they were able to have this kind of experience and get out into a clean, pristine, functioning wetlands like this and see how it works, there'd be no question about whether or not we should restore every pocket of marshland and wetland we've got left.
This is all that's left of 2,500 acres of the original estuary of the San Gabriel River. The reason that this 100 acres has survived on this side is largely because of the power plant that you see on the horizon here. The water which is pulled up the Cerritos channel and through the power plant and discharged into the river has kept this part of the wetland viable, while the rest of it degraded into what you see on the other side. And over the years, starting around in the 1920s, they started oil recovery operations in here. They diked and drained and recovered oil until still up to the present. One of the advantages for a restoration here is the existence of, alongside of it, of a functional wetland. When you look at that, it may look pretty nice, but in fact, it's a very degraded wetland. But as degraded and stressed as it is, it still has most of the genome intact. Most of the animals who ought to be here are still here. Even though the web of life is tattered and torn, it's still here. We still have flagship endangered species like tidewater gobies. We still have flagship plants like bird's beak. In fact, here is a variety of a federally listed endangered species, birdbeak, in a bush form that is only found in this particular wetland. A lot of the larger endangered species that you find here, like the osprey, that bald eagles come through twice a year, migrating through, can move around. But the important ones, the less visible things, like the little tidewater gobies, can't move. And even though there's not many of them left, there's enough right here in the functional part of this wetland to repopulate a restored wetland alongside of it. This is a Belding savanna sparrow, is another listed endangered species that you see directly in front of you. All of these creatures, particularly the endangered ones, but all of them, are here because the habitat's here. They're endangered because there is almost none of that habitat left. Once you have the habitat, you'll have the creatures. Even ones who were thought to have disappeared magically reappear once the habitat reappears. The site that you're looking at is the site of the Tongva Indian village of Pavungna, which sat on the divide between the watershed of the Santa Ana River and the San Gabriel River. There's about 14 archaeological sites on the top of the hill there that would be preserved under the acquisition of this whole area for a restored wetland. The area in front is called Gum Grove Park. Contains a number of endangered species.
About 2 years ago, I decided that I'd adopt this wetlands and start cleaning it up. And the problem was that as I cleaned up the area, more and more debris came in. A gentleman by the name of Doug Coulter from the Los Cerritos Task Force had a great idea, and he came out with some 4-inch irrigation pipe, and he constructed a mini boom. Well, we saw that it was working, and what I did is I extended it to the full length of the wetlands. Now, we designed this boom with an opening that will not allow any trash in. However, the small boats and the kayaks can come in and use the boom. Here we are at the site of the previous photo that you just saw that was smothered in debris. Came in here, raked it clean. Thought I did a lot of damage to the area, but I had no choice because of the debris. But the wetlands, it made itself. It made a big comeback here in just a few months. John Bradley with the Fish and Wildlife Service said this is the most pristine wetlands that he's ever seen in Southern California in the last 25 years.
Okay, in salt marshes, in saltwater marshlands like this, there are only a few kinds of plants that are commonly here because salt water will kill most regular land plants. But if you get up to the highest parts of the marsh, where the water comes up only on the highest high tides, you get this saltgrass material, okay? Looks sort of like coarse Bermuda grass. And this can get covered by water only a few times a year. As you get down a little bit deeper, a few inches deeper in the marsh, with the ground a few inches lower, the saltgrass disappears and you get pickleweed instead. And pickleweed looks like you took a bunch of little dill pickles, miniature dill pickles, and glued them together end to end, which is why it gets its pickleweed name. And then when the ground gets a little bit lower than where the pickleweed will grow, you move on down a notch, a few inches deeper, and you get cordgrass or Spartina grass. Now when fish hatch out of their eggs in marshes like this, which an awful lot of fish do, when the eggs hatch, the baby fish, little half-inch, quarter-inch, sometimes three-quarter-inch baby fish, will follow the tide water up. As the tide comes in, the baby fish will move up higher and higher into, first of all, the cordgrass and then the pickleweed, and they'll hide among the stems of the grass and eat little bits of material that they find on the edges of it, little crustaceans and little shrimp-like animals. And then as they move up further than that, they'll get into the base of the pickleweed stems and do the same thing. And as you can see, looking at the pickleweed and cordgrass around my feet here, it's pretty difficult for predators to follow baby fish into this kind of an environment. And this is what makes marshes like this so really important to ocean fish, because 2/3 of the fish that we have in the oceans off of California, 2/3 of the species, 2/3 of the volume of fish that live in the ocean out here spend their baby and childhood years in salt marshes like this. Now, California has a very effective, in terms of money brought in, commercial fishing industry, and also a very effective sport fishing industry, worth a lot of money to a lot of people. A lot of income comes from this, and a lot of food comes from it for people. And 2/3 of those food fish that we eat from commercial or sport fishing, 2/3 of those fish spent their infancy and childhood in marshes like this. And much of the California fishing industry has declined sharply over the last 10 years. And one of the major reasons why it's done so, if you read about this, you'll read a lot about pollution in the offshore water, and you'll read a lot about overfishing of the fish populations. And that's all true too. But one of the primary and possibly the biggest reason why those fish populations are dropping is because the marshes in which the babies would have survived aren't there anymore. And if we don't have enough fish out there to serve the human fishing industry, you can imagine what's happening to the natural food supply for the sea lions and the seals, and the otters and the small whales and the dolphins. These are all fish eaters, and their food supply is dropping just like our fishing harvests are dropping. And one of the primary reasons why this is happening is the loss of marshlands like this to serve as fish nurseries. Most birds that live in the marshland out here, and a lot of birds come to the marshland, most of the birds that live in marshlands are carnivores. This little mallard here is one of the few birds out in this area that's actually an herbivore, a plant eater. And as you can see, she thinks that pickleweed is not bad here, you know, kind of a nice tang to it. Pickleweed actually has a rather salty, tangy taste to it. Yeah, pretty good, huh? Okay, yeah.